Hello everyone, this is Jeff Grob. I'm the developer and programmer for WINGRIDDS, and in this continuing series of tutorial videos today, in part 3, we're going to go over the WAFS GRIB conversion process. In part 2 we went over the regular GRIB conversion, and the WAFS GRIB is unique because I covered it real quick in part 1, video 1, and the WAFS GRIB are the global models subdividing across the Earth into 8 equal sectors, which was created to ease the amount of information that was distributed across the international global telecommunications network. So back in the 80s and late 80s and 90s, when it was first created, the didn't have the real big internet speeds like we have now. So they had to subdivide and shrink the data sets, so the users in international areas, if they wanted to look at the global data but only over their local area, they could just download the individual sector that was covered their geographic area, which reduced the download time and the processing time for computers that were a lot slower way back when. But we're going to go through the process here, a few demos, and how WINGRIDDS does that, some things to look out for, and improve your familiarity with it. So let's go. Again, WAFS stands for World Area Forecast System. And if we go look inside the WINGRIDDS User's Guide, I've gone to a page here that, let's scroll down some. Select area for gridded data sets. This is a good way to visually explain how the data sets are spread across the Earth. And here we are on page 35 of the WINGRIDDS User's Guide. And it says up here that the surface of the Earth is divided into 8 areas, or octants, identified by the labels I, J, K, L, that would be for the Northern Hemisphere, and M, N, O, P, which are for the Southern Hemisphere. And so it goes on to describe that if you don't live in a geographic area, you don't have to download that sector if you have limited bandwidth for your telecommunications. Something to keep in mind if you need to process more than one octet. Actually, let's back up a bit here. Let's give you the visual of it. These are the World Meteorological Organization WAFS global coverage of grids, and the GFS, which was the MRF way back when, and then became the AVN, but now it's the GFS, the Global Forecast System put out by the U.S. National Weather Service. Their WAFS sectors are described like this. The Northern Hemisphere, again, is assigned the letters I, J, K, L, and the Southern Hemisphere is M, N, O, P. And then also assigned the numbers 37, 38, 39, and 40 for the Northern Hemisphere, and 41, 42, 43, and 44 for the Southern Hemisphere. And if you notice the longitude lines where they divided the Earth down, a little bit different than what would be expected. 330 degrees east, and then 60 degrees east, and so 0 degrees longitude is right in the middle of there. Then the next sector goes from 60 to 150 east. Then the next sector is from 150 to 240 east, and so 180 degrees, or the international date line, is right through the middle of those 2 sectors. And then the last remaining 2 sectors are from 240 east to 330. Now the ECMWF, they have their own WAFS version, and of course it's different. Their octants have the same letters. Well, the Northern Hemisphere does, should I say. Starts at I, J, K, L, starting at 0 degrees east, working way across the globe. But then the Southern Hemisphere runs in reverse. from 9, 10, 11, 12 number-wise. Their numbers go from 1, 2, 3, 4 from east to west instead of west to east. And the southern hemisphere goes from 9, 10, 11, 12 from east to west instead of west to east. If you notice, they're missing 4 that are in the middle. Well, there are actually 12 octets for the ECMWF data set. These 4 have full global coverage, but also ECMWF throws in 4 more sectors for the equatorial region. It's about 30 or 40 degrees north and south of the equator. So that would be sectors 5, 6, 7, and 8 across that area. And then 9, 10, 11, 12 cover the southern hemisphere, the complete southern hemisphere. One of the other differences between the GFS and the ECMWF GRIB is that the grid spacing down here it states that the WMO standard that the GFS adheres to uses 1.25 degree grid spacing, and the ECMWF uses 2.5 grid spacing. So there will be slightly less data in the ECMWF than there is in the GFS. Your grid points will be spaced farther apart, so keep that in mind. The conversion process is similar to the process that was in the regular GRIB processing, except that a few more extra steps involved. Let's shrink this down. Let's open up where we were. The utility that converts the WAFS GRIB files to regular WINGRIDDS format is called GRIB to PCG32.exe. That is the utility. And something to keep in mind. Looking over here in the directories, the data is stored, the WAFS GRIB data is stored in the WAFS directory, WAFS GRIB WINGRIDDS directory. And if you notice within the WAFS directory, there are 8 directories for the one for each octant set. I, J, K, L, M, N, O, P. This was done because it used to be that the GRIB files for octant I were named the same as the GRIB files for octant J, and the same for octant K. Well, you can't put the same file names excuse me, you can't put the same file names in one directory and expect to one would overwrite the other, so you got to break them down into their individual directories. Now, when GRIB to PCG, when the utility starts to go through this data, it's going to look through all of the directories for what data is there. And it doesn't really matter what files are in what directories. Because if you stick, say, the J octant files in octant M directory, it's still going to see them and it's still going to process them. This was just done to keep the order in the, if you will, in the chaos, if you will, of all of the files having the same file name. Now, if all of the files for a model run for all the different octants have different unique files, they could all be put in the same directory. It doesn't matter. They'll still be seen, they'll still be processed. It's not a requirement to put octant I GRIB data files into the octant I directory. Just something to keep in mind. But if we open one of these up, our little experiment, our little demo that we're going to be doing today is just going to be covering 12 hours. We're not going to do a full 140-hour model run. And also, that's one of the things, the WAFS GRIB data does not usually do the full model run out to 384 some odd hours. They have it truncated down to usually only about 140 hours or so. But for our experiment, for our demo, each directory has 12-hour set every 3 hours. If you viewed the tutorial number 2 explaining how the regular GRIB data is processed, I went through all of the files that are used in the initialization and that are referenced in the processing of the GRIB data for the discovering the parameters, the mapping, navigation, things like that. GRIB to PCG32, the processing of the WAFS GRIB data is similar but a little bit different because it doesn't use all of the information that regular GRIB does. It still gets the location information from the wingmode.dat file, which is in the user directory, but that's all again done within WinGrids through the properties configuration about where the directory is located, that the GRIB data is located, and where the destination directory is. It still references the grib2parm.dat file. For the parameters is the grib2 parameter listing that associates the discipline, the category, and the number ID. That's what these 3 columns are. It's part of the grib2 standard that uniquely identifies each parameter. There's a long exhaustive list for all of these, and all of these can be referenced in the grib2 file format definition documentation. But that's what this file does. It reads and reads in all of this information, so when it comes across discipline 0, category 1, number 0, it knows that that is specific humidity, and it will be assigned the SPFH identification when it goes to create the inventory in the WinGridd's data file. So that's what this file is for again. It also uses the grib model.dat file, which associates the model ID number that is in the GRIB product definition section, or the equivalent of the in GRIB2, and then it gives it the 3-letter model ID name that will be assigned as part of the file name that's created. So that's all listed in here in the grib model.dat file. And that's really all of the files. Also, there's the gribparm.dat, because in case you run into a WAFS GRIB set that is still GRIB version 1, not GRIB version 2. This is the GRIB version 1 file that identifies the number to the parameter ID. GRIB version 1 only had 256 numbers that it could assign a specific parameter, and so that's one of the advantages that they changed. One of the things they changed in GRIB 2 was to give it a much larger data set capability for GRIB parameters. And so that's why there's only a single column for the GRIB 1 parameters here. And those are mainly all of the data files. It doesn't use any of the GRIB skip. It doesn't use MOS or anything like that. So one of the next things that it does is we'll come down to here. We'll hold that. Let's open up WinGrids, and since we've already downloaded the GRIB data, we're going to process it. So we want to convert WAFS GRIB files. This dialog will open up. And again, going back to the subdivisions of the Earth, scroll back up here into these sectors. You need to tell GRIB to PCG32 what sectors you want it to process and convert. You may have downloaded all 8 sectors for whatever reason, but you only want to use, say, 2 or 4. That's one of the things that's unique about the WAFS GRIB processing is that the GRIB to PCG32, the utility, will glue these adjacent sectors together to make it a unified data set. And so, say you wanted to ingest P and L, well then it will glue these two sectors together and to make it one uniform or unified data set. Or if you want to glue I, L, and M and P, these two across this area here, you can do that. We'll do that also as part of the demonstration. But within this dialog, this is where you select which area you want the GRIB to PCG32 to use to glue together. This is the listing of all those options, and every option is available in here. And they're broken down into groups. Like for global coverage, you have all your octants listed over here, and this is the description. And these 3-letter sets on the left side, if you go down, each one has a unique 3-letter set. You may ask yourself, well, where does it get this navigation from to know whether you want to be centered at 0 degrees or centered at 180 degrees or whatever? These 3 letters on the end correspond, if you go back to the directory within the GRIB directory here, and you scroll on down, you have these octets files. And you notice they have 3 alphanumeric characters after the period. These 3 letters that are on the ends of these files correlate to the 3 letters that are here in this area selection menu. For example, the globe centered on Greenwich. So we have octants O, P, M, N, and then K, L, I, J. So that's WFG. So let's go look down WFG, that's right here. So let's open that up and let's see what that says. Here we're looking at our 8 sectors, where it says here it's 8 WAFG, and it has all your octants listed in the order that it wants them processed. So 1, 2, 3, 4 starting at O, P, M, N, and then 1, 2, 3, 4 starting with K, L, I, J. And then the second column is whether it's northern hemisphere or southern hemisphere. So 1 is northern hemisphere and 2 is southern hemisphere. And then you have your navigation information down here. So let's compare this centered on Greenwich with WFD, which is centered on the dateline. So WFD, octets WFD. Let's open this up. Let's move to another view so we can put them side by side here. So we have again the WAFG here, WAFD over here. WFD is centered on the dateline, WFG is centered in Greenwich. So again we have the O, P, M, N, K, L, I, J for the octets ordering. Over here we have M, N, O, P, I, J, K, L for the octets ordering. So this defines how the octets are ordered and how they're glued together and what goes on top and what goes on bottom and things like that. And if you notice, the navigation is a little bit different also. So that's what these letters here, these letter groups, are associated with these files, these octets files in the GRIB directory. Okay. But let's go down and let's again we have the center hemispheric coverage centered on the half of the northern hemisphere and the southern hemisphere. Then we have certain selected areas for PL2, that'd be the centered on the Caribbean and the Americas, and then specific northern hemispheric areas next, and then specific southern hemispheric areas next. Then rectangular pole-to-pole areas like PL and PL or PMLI, things like that. So let's go on and let's let it run. Let's do an experiment. We have our data. We have the information that we need. And so let's go do an example of the Caribbean and the Americas. And so we've selected that we want to process the WAFS data. And so this is the dialog that pops up. And when we click on this, this will start the process. This will initiate GRIB to PCG32 with the information that it needs. So let's do that. We double click on it. And what it did there was it went through an inventory of all of the GRIB data that was in all of the directories. And then the next step was to find out specifically what GRIB parameters were in what octets were there and how many forecast hours and things like that. The next step was matching to make sure that every octet had the same GRIB parameters. And that is one of the things with this, that if you want to process octet P and octet L and you want to glue them together, you want to make sure there's a requirement that all of the octets have the same parameters on the same levels. Because, for example, if you say in octet P you may have the 850 millibar heights, but in octet L you don't, it's not going to process that GRIB parameter for that level. It'll try to search through the rest of them to make sure everything else matches, but if there is a parameter that's missing and that's not available in every octet that you request, it's not going to process that parameter for that level. So that's something to keep in mind. And the processing was completed, at least it appears that way. So let's go look up. As with all of the utilities, this creates a log file. GRIB to PCG32.out. OUT is the log file, and with all of the other, log files, this is in the root directory for WINGRIDDS. Scroll it on down. GRIB to PCG32.out. So this is the log that shows all the processing that was done. And this is very valuable for you to learn as a user. That will help you troubleshoot what GRIB to PCG32 is doing, or any of the other utilities for that matter. And that will help you to troubleshoot if you run into any problems or things like that. So we'll go through this real quick. The argument count was 1, which goes to show that, we'll go up here. There's only one argument that goes if you enter it in at the command line or that's executed. We'll go through this also. There's only one argument that goes with GRIB to PCG32. That is that telling it which octets to process. If you just execute GRIB to PCG32, it will not process because it doesn't know what octets to read in. It doesn't know how to glue them together or which ones to process. So this octets.pl2 file tells it what octet files, what octet data sets to process and to utilize and to create as an output file, and if any of them need to be glued together to make sure that they're there. So this is a requirement, but it's the only argument that takes. And it says the sector again was the octets.pl2. Then it read the win config data file, the WinG mode data file. That's where it gets all of the directory information from. Then it says pre-processing the WAFS GRIB data files in this directory, and then it's going to go through each one of those GRIB data files, each message in there to identify what grid it is, the grid type, the grid ID, the octet ID, the navigation, and the parameters, and things like that. So it's going to step all the way through each one of those files and each one of the those directories. And notice it says that this is GRIB edition 2. And so we're going to go on down through until we find where it actually does the organization. Whoop, let's back up. Okay. Says, that's right about the middle, it says GRIB collection complete. It says pre-processing complete, total ingest error 0, GRIB count 3,632 GRIB messages. GRIB collection is complete. Then it calls the order inventory routine, which is sorting all the GRIB data. Total number of records. It searched the octants. How many octants did it come across? It came across all 8. So total number of 8. Searches the number of forecast hours. There were 5 forecast hours. And it searches for all the different types of parameters, and it lists the parameter types. So there were 11 different types of parameters. It searches the different level types. There are pressure levels, there are surface levels, there are boundary layer levels, there are all of these different types of levels, and so these numbers are associated with the level ID type, whether it be pressure, whether it be isentropic, whether it be boundary layer, sigma, whichever. So there are 7 different types. Then it went and searched through the actual pressure levels themselves. There were 16. There were no ensemble information available. And there are WAFS ensemble GRIB data files available through INSEP. And this will process them. You got to kind of dig for them, but they are there. It says the sorting complete. It says the reference file is the GRIB octets.pl2, and so it says the octants to be used will be octants P and L. So there will be 2 loops used. And then it starts processing through. And again, it creates the grid navigation for the projection onto the screen. It adds your latitude, longitude, the heights, the Coriolis effect, the Coriolis parameter, should I say, the DMAP, which is the grid spacing, and all of these different things, which were standard in the other. And then it progresses on through. For each octant that it needs to collect, it makes sure that it's in. It looks for octant P, and then it looks for the data for octant L, where that is, and then it grabs it, and then it glues it together, and then it saves it. Because you notice, octant P information, it searches octant L information. Make sure that's there. It's adding the grid pressure maximum. And so it goes on through all of the GRIB files, all of the different forecast hours for all the different parameters, and collects everything that has been instructed to do. And again, at the end, this information shows that it's at the end of the data files, and so stop it here, stop it here, stop it here. And just like the processing the regular GRIB data, so saving WINGRIDDS inventory records, so it goes through data process for sectors P and L, and then it lists all of the parameters for all the different levels like it did before. If you notice, the WAFS GRIB data set, as part of the reducing the data set size for the faster data distribution, is a much smaller data set for as far as parameters and levels as compared to like the GFS or the NAM or something like that. And so it's a much smaller data set. And the file was saved as WINGRIDDS grid data, which is of course where the default savings are at. September this, and so let's go look there in the GRIB data, and there it is. And let's go back up here real quick so we can explain the data file naming. There we go. Well, let's keep that. Drag that down here. Drag that up there. Shuffle everything around. Okay. Our file name was called September. I downloaded this quite a while ago, so I'm just using it as a demo. SCP would be for the month, September. 21 would be the day of the month, September 21st. The year, the last two digits would be 17, so September 21st, 2017. Then the hour of the model run was 12, so that's the 12Z model run. Then the three-letter designation was GFS, and so that's the Global Forecast System, and it ingested octants P and L. Now, if you ingested octants MNOP IJKL, it would come out MNOP IJKL. So all of the octants that are utilized in the processing and in the final data file are listed in the file name. So let's scroll back down here again to where we were. Okay. Let's open up WinGrids real quick. Let's see if what we did was correct. And so we open it up, and there's the data file. So let's look at the full area, and we can here follow along what the command is and typing it up. The area command, if you want to look at the whole grid data set, you just go area space 0 space 0 space 0 for latitude space longitude space the vertical latitude, size, and degrees of the area. So if you put all zeros, that'll default it to the full geographic area. So let's do that. You notice it expands out. So let's look at the heights. Like I said, defaulted to the 850 millibar level, which is located down there. So let's go height. And you can see there is no data to the east, to the west of the sector, and there's no data to the east of the sector. Just along octant L and octant P, which is in the southern hemisphere. Now, for example, like I said, all of these utilities can be called from batch files from the command line, and so let's do an example. Let's look at something here, convert WAFS GRIB files. Let's scroll on down. Let's look at doing the pole to pole. Let's process PMLI, which will make a larger geographic coverage of that. And so that's PL4. Those are the three letters we need to look out for. PL4. But we don't want to do it from here. We want to pretend that we have a automation or a batch file run. So let's type this out. GRIB2 PCG32. Learn how to type. GRIB2 PCG32 octets dot PL4. And let's see what that does. So that's going to go through the same thing again. It's going to inventory all of the GRIB files that are there. Again, it's going to make sure everything is consistent, everything matches. But now, like I said, we're going to be processing 4 octets, not just 2. We're going to let it process through. As it progresses along. And since we're processing 4 sectors instead of just 2, it's going to take a little bit longer than just doing the 2 sectors. And it doesn't really matter as is going through and processing the data. If it doesn't matter that it does it in forecast hour order. As long as it knows when it builds the inventory, as long as it knows what data parameter for what level for what forecast hour is located where, it'll find it and you will be able to display it. Now you see that we can stretch this out a bit. We have all of our forecast hours there again, saving WinGridd's inventory records, and now for P, M, L, and I sectors. And if you notice, the data file is the initials, the date time group is the same, the model is the same, but now it's PMLI for the extension instead of just PL. And if we open up the Windows Explorer, you can see here there's the new data set. Now something I didn't mention before, I need to mention here. There are two different file versions that WinGridd's uses. There's what we spoke about with the regular GRIB processing is the newer data file version, and of course this is separate from the GRIB version. But since we're working with potentially such large data sets, this file that's created here only contained the inventory, and the rest of the data was stored in the model, the datetime group, and the actual data, scalar vector data, was stored in these files that are individual for each forecast hour. However, in the original PC Grids, WinGridd's file format, everything was stored in one file. All of the inventory, all of the navigation, and all of the actual scalar vector data was stored in one file, in a single unified file. And that's how GRIB to PCG32 does. It's all stored in one unified file. So this is the only file you need to save if you want to archive it someplace. So that's something to remember. But now we can open up WinGridd's again. And let's open up the 4-sector version. We can compare the two. It says it has the same navigation and everything. Nothing's changed. We can do the area again. And if you notice, the area shifted a bit towards the east because it's centered in the middle of the 4 octets, not just in the center of the 2. But if we do HT here, which is the heights, we show the heights. Now you see the data goes from 120 degrees west through 60 degrees, which is where the first octet ended, and then it goes all the way to 60 degrees east. And so we have all 4 octets glued together to make one unified data area. We can overlay the wind on that. And so that's basically the processing for the WAFS data sets. That if you pick and choose different octets, it'll all process still the same. And of course, always remember, yes, the output file was modified, and so all of your debugging and detailed information is in the GRIB to PCG32.out file. This is what you need to reference for any forecast, or excuse me, any troubleshooting. And if you don't get your inventory at the end, then you've got problems. But GRIB to PCG32 is pretty much error-free, bug-free, since the data set has not changed and in many, many years. So it should be very reliable operations. So thank you for viewing this tutorial. I hope it helps, and have a great day.